Today's lesson is graphing cosecant and secant graphs. If you can graph sine and cosine, you can graph secant and cosecant very, very easily because they are reciprocals, which means they're based on the original graph. So we are going to graph cosecant x. And what we're going to first think of, since cosecant goes with sine, the very first thing we're going to do is we're going to graph a sine graph. And that's going to allow us to draw our cosecant. So our sine graph starts at 0. It goes up to 1, goes back to 0, goes down to -1, and goes to 2 pi. Obviously, I didn't do anything to the period because it's just sine of x. That's all I'm graphing is sine of x. And this isn't my main graph, so however you delineate between a useful graph and your main graph, do it now. I use little dashes. I actually write it very, very light. A lot of times if I have a pencil, I write it very, very light, and then I put the other thing in heavy. All right, so that is just regular sine of x. See where sine of x equals 0? Sine of x equals 0 because technically this is the point 0 over 1. This is the point 0 over 1, which makes it 0. When we go to secant, we take the reciprocal of it. We take the reciprocal of it, which would be undefined. That would be 1 over 0. So anytime we have a 0 on either our cosine or our sine graph, if I'm trying to do secant or cosecant, what you're going to do is you're going to do little dashed lines to say it's undefined there. And you'll see why in just a second. So at any place that it touches 0, I'll put those dashed lines. And there's one at the y. I just don't know how easy it is to see. I'll try to splatter it apart. There. All right, to do our cosecant graph. Where sine is positive, cosecant will also be positive. It can help you with the graph. So where sine is positive, cosecant also needs to be positive. And what the reciprocal is going to look like is it's just going to go in the opposite direction with 2 arrows on the end. So it gets really close to this undefined, but it never touches it. It just keeps going up forever. So our cosecant value can get really, 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 really big. On the other side, we're just going to go the opposite direction. And that's our graph of our cosecant. If you know how to graph sine, you should be able to graph your cosecant. As long as you remember your cosecant is undefined at the zeros, and instead of going down, it just goes up. I want to bring one more fact into this. Range. And I did put it on the homework because people over the years have struggled worse and worse with understanding what range is. Range is the lowest point to the highest point your graph actually goes to. So in this case, the lowest point my graph goes down to is -infinity. Whenever you use infinity, you always use a parenthesis because you can never reach it, so you use a parenthesis. Now, if I'm traveling along this line and I'm going up, 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 this is the last point this goes to because then we have to skip and get to this next point. So it's -infinity right up into this -1. And since there's a closed dot right here, it means it includes -1. So you are going to put a bracket. Just a quick recollection, a bracket means it includes. I'm going to need to shift this over a little bit. I wrote a little big. All right. Then you're going to use a little u because you're unioning 2 things together. We start at -1 with a bracket because it is included. It is a closed dot. So +1. And then it goes up forever. So it goes to infinity. And that's our basic graph of cosecant. Let's go ahead and graph secant, even though if you follow these steps, but with cosine, you'll have your secant graph. So in order to do a secant graph, the first thing I'm going to do is I'm going to graph a cosine. But I'm just going to use dashes or write very, very light. Cosine starts at 1. It comes down to 0. That's a terrible. Retract, retract, retract. Cosine looks something like that. And now what I want are dashed lines wherever it's 0. Once again, wherever cosine is positive, secant will also be positive. It's just going to go in the opposite direction. So we're positive here, so instead of here, we just flip it. We flip it like a cup. And since we only have half of it there, we just have to graph half of it. Then we go to the negative. Our secant's also going to go in the negative direction, like that. And our final one is going to go up like that. The range is still the exact same, though. Our range in this case is going to be negative infinity with a parenthesis, because we can't include in negative infinity. We can never reach it. Negative 1 is included, so we put a bracket around it. And we're going to union that with 1 to infinity. That is our range. Lowest to highest point, skipping anything that's not included. I think it just gives you some step-by-step how to graph it down here, but we just went through it. You can read that on your own. Questions on graphing secant or cosecant? It just takes practice, guys. It just takes practice. And I promise you we will have a quiz on how to graph these along with tangent, because we'll learn how to graph tangent next week. We'll have a quiz because I want to make sure you can graph them first before we take like a test on it. All right. I need to graph cosecant of 2, quantity x minus pi over 2. Whenever you see this, you can, if it helps you at all, put these in brackets to recognize, but it really is just everything attached to the cosecant. So the first thing let's talk about is the period. Let's take care of the period first. The period is 2 pi over that b value, which is 2. And we don't have to do anything with the b value because it's already factored out. It's already factored out. We already have x minus pi over 2 inside parentheses, so we don't need to factor it out. So that means the period is pi. We're going to do the same thing we did with sine and cosine. We count out 4 units, 1, 2, 3, 4, and we write pi down. Then we do our half multiplied by 3. Well, pi divided by 2 is just pi over 2. Pi over 2 divided by 2 is pi over 4. Pi over 4 times 3 is 3 pi over 4. And now the period is taken care of. I don't have to worry about it at all. It's going to shift. What direction? It's a negative. Mary? Right. It's going to go right. It's going to go right pi over 2, or pi over 2 units, yeah. All right, since it's cosecant, I'm going to first graph sine. When I'm thinking cosecant, I'm thinking sine. Use that to get my cosecant graph. So once again, we are shifting right pi over 2 units. Pi over 2 units with sine would look something like this. It goes down. I'm going to go ahead and make this 1 and this negative 1, so I'm going to skip a dot. It's going to go up. It's going to come back down. It's going to go here. It's going to go here. All right, any place my sine graph is 0, I'm going to put vertical asymptotes. Now that I have my sine graph, I just need to put my cosecant graph above it and below it. So we're positive here. We're just going to flip it in the positive direction. So we're going to go up. We're going to go up. These are negative, so we have to go in the negative direction. We're going to just, drop those down. So once again, if you know how to graph a sine graph, you should have no problem with cosecant, because you just graph your regular sine graph, whatever needs to happen, up, down, left, right, whatever you need to do, change your amplitude, and then you just go on the top of that mountain and draw it up, and on the bottom of that thing, you just draw it down. All right, let's do one more. Yeah, sorry, Russ. You're going to on your homework? Okay. Every single one, I think I asked you to do the range. Yeah. Okay. Do you want to see the range for this one?
Wasn't just the same as
it's going to be the exact same. Yeah, that's why I didn't do this one. We could do the next one because it'll be slightly different.
Okay.
We'll do the range of the next one. All right, so this one is secant, so I'm thinking cosine. I need to graph cosine first, and then we just flip everything to get our secant graph. So first of all, the period will be 2 pi over 2, which equals pi. Cool, we just did that. So it should be pi over 2, pi over 4, and then 3 pi over 4 as well. Oh, yep, you're 100% correct. I jumped ahead of myself. I was hoping it was the same. Our period is just 2 pi over 1, because that came from there. It is going to shift right pi units, and it's also going to shift down 1 unit. And I'm going to put a little slot in there that says amplitude is 2. All right, let's do our period. The period is 2 pi. 2 pi is something we dealt with a lot. 1, 2, 3, 4. 2 pi. We'd have pi over 2, and we'd have 3 pi over 2. I'm graphing cosine. It is down 1 with an amplitude of 2, and we also have to go right pi units. So we should mark this as 1, 2, 3. Let's make this -1, -2, -3. I'm going to go ahead and move the sinusoidal axis. So that's how I'm going to do this one. I'm going to move the sinusoidal axis down 1. All right, now we need to go right pi units, and then amplitude of 2. So we need to go right pi units and have an amplitude of 2. Usually cosine starts 1 unit up, but now we're going to go 2 units up because our amplitude is 2. So at pi units, maybe I'll do this in red, we're going to go up 2 because that's our amplitude. Our amplitude is 2. Most of us did really well in the graphing, so I'm not going to spend a whole bunch of time on this. But it goes up 2, then it comes down 2, and then it goes back up to those 2. And that is our cosine graph. So that's my cosine. All right, then what we're going to do is we're going to go ahead and make our vertical asymptotes wherever cosine is 0. So that's right here. And that's right here. Then we just take wherever it's positive and flip it to the positive direction. We'll take wherever it's negative and flip it in the negative direction. And we finally go to the last part and flip that positive in the positive direction. All right, I'm going to tackle the range on this one, because in the homework you do have to use the range, and this one is different. Well, we still start at negative infinity. Our lowest point on our graph is negative infinity. So we'll use a parenthesis, negative infinity. And we're going to go all the way up until we get to negative 3. So we go all the way up till we get to negative 3. And we're going to use a bracket because it includes negative 3. And then you're going to union that with this top one. Well, this top one, both of them start at the same place, right? So our next point is 1. Our next y value is 1, and that goes on forever. So it's going to be union with bracket 1 to infinity. That covers all the possible y values. That's your range. Your range is all your possible y values. All right, questions on that? All right, like I said, if you know how to graph sine and cosine, do it, and then graph your cosecant and secant on top of it. It just makes it's probably the easiest way to graph these instead of trying to picture where it's going up and where it's going down. So you graph it, make your vertical asymptotes, and then flip everything. Flip your positive in the positive direction, flip your negatives in the negative directions. Nicholas?
Why wouldn't the asymptotes be like where the cosine graph meets the x-axis?
Because it will actually never meet the... I see what you mean. But it's your sinusoidal axis.
Okay.
It's always going to be your sinusoidal axis. That is your original 0. So Nicholas, you're basically moving this 0, which would be your asymptote, and you're shifting it right and down. All right. So you are shifting your vertical asymptotes along with where you'd shift your 0. So I guess I should correct that and say it is where it intersects your sinusoidal axis, which is technically where your cosine was 0, and you just shifted it over and down. Okay, so it is always where it's in your sinusoidal axis. All right, we're just going to do a couple examples of these ones that people tend to struggle on just a little bit. These are creating a sine, and this time we're going to create a cosine equation given specific information. So in this case, they tell you the amplitude is 3. Your amplitude is 3. So you can go ahead and start writing your equation because it's going to be 3 times sine of something. Because your amplitude is 3. It's always going to go right out in front. All right, the next bit of information they give you is your period is pi over 2. Remember, pi over 2 helps you find your b value, but pi over 2 is not your b value. You're going to take that period being pi over 2, and you're going to set it equal, so pi over 2 equals 2 pi over b. Because that is how you find your equation. The period is 2 pi over b. In this case, it equals pi over 2. Well, this is just solving it. You multiply both sides by b. So we multiply both sides by b, and we have b times pi over 2 equals 2 pi. And the next thing you do is multiply by the reciprocal of pi over 2, so that'd be 2 over pi. So we're multiplying both sides by 2 over pi, which is going to be b equals, your pi's will cancel out, and you're just left with b equals 4. If you need to do more steps, then do more steps. If you need to do more steps on that, then do more steps. You don't have to copy down just what I am doing. Remember, these are the shortest possible notes that I'm doing. Doesn't mean this is exactly what you're taking as notes. You take as many notes as possible. All right, so our b value is 4, so that's going to be the next thing I plug in. Our next thing is our shift, left or right. Well, it does say that the shift is pi over 4 to the right. So that's going to go there. Right is going to be negative, so it's minus pi over 4. And finally, it says it shifts down 3. So that's going to be minus 3. I want you to do the next one. Try the next one if you haven't already. And then we'll go through that one together. All right, we should have started off with the amplitude being 2. So it's going to be 2. And the only difference here is we're going to use cosine instead of sine. Doesn't change anything. It's just 2 cosine. The next value you need to find is the b value. Well, the b value deals with the period. Your b value is not pi. I can't stress it enough. If they say the period is pi, that doesn't mean your b value is pi. It just means you're going to use that to solve for pi. So we're going to have 2 pi over 2 over b, I'm getting ahead of myself, is going to equal pi. Multiply both sides by b. You're going to have 2 pi equals b times pi. Divide both sides by pi, and you're going to get b equals the deuce. So that is 2. Next, we're going to go x. It says it goes right pi over 2, so that's minus pi over 2. And it goes up 4, so I add 4 to it.